Hello, my name is Alfredo Cervantes, and I'm doing the valence bond theory for iodine trichloride. So, to begin the valence bond theory, we have to start with the Lewis dot structures. Iodine has 7 valence electrons. Chlorine also has 7 valence electrons, but since there are 3 chlorines in this molecule, we have to multiply those valence electrons by 3. Altogether, we get 28 valence electrons. So, as you can see, I already completed the Lewis dot structure, but there are 5 electron groups for this molecule. 2 of these electron groups are free electrons, meaning they're lone pairs. They don't bond with anything. So when we have 5 groups, we can conclude that the electron geometry is trigonal bipyramidal. And since there are 2 free groups, then we'll understand that the molecular geometry is T-shaped. Next, we'll be using the valence shell electron pair repulsion theory, or VESPER for short. This theory is used to predict the way that the atoms will be arranged in a molecule. This is called their molecular geometry. They are arranged in this T shape because this is the farthest away that the electrons can get. So these lone pairs right here, as shown earlier in the Lewis dot, they have a much stronger repulsion strength than the bonded pairs that are right here. So this forces the angle between these 2 chlorines to be greater than 180 degrees. And since these chlorines right here are pushed down, the angle between these 2 chlorines would be less than 90 degrees. And finally, we get to valence bond theory. And iodine at its ground state, which is its lowest energy level, only has 1 spot available to bond to create the full 8 valence electrons. So in order to make 2 more spots available for ICl3, it actually promotes one of its electrons from its 5p orbital to its 5d orbital. So this requires a little bit of energy. And now the excited state of iodine has 3 spots available for bonding. Now the molecule can bond. So what we would do is show that this is hybridizing, and we draw a circle around all the electrons that will hybridize. These all make the sp3d orbital. So, since there are still 3 available spots, we have 3 chlorines. And each of these chlorines has 1 free electron. These all bond with the 3 available electrons in this sp3d orbital. And this is now the bonded state for the molecule ICl3. So this is the contour diagram. It's pretty similar to the VESPER diagram. It shows how the molecule is shaped and how the electrons are bonded. So these right here are the 3p orbitals of chlorine, these bonded ones right here. So this is chlorine, and this is the 3p orbital. Same for this one. And also for this one. These are where it's bonded, and right here are the lone pairs. And here are some 3D models that show what I am talking about. So this one right here, it's T-shaped and it has the two lone pairs.